Welcome to the second lecture on measures of dispersion. Our learning outcome is to determine if a value is an outlier. So what is an outlier? An outlier is an extreme value that lies outside of the overall pattern of the data. But how do we determine that? Well, we use the interquartile range. And an outlier is any value which is either greater than the upper quartile plus 1.5 times the interquartile range, or less than the lower quartile minus 1.5 times the interquartile range. And remember that the upper quartile is Q3, the lower quartile is Q1, and the interquartile range is Q3 minus Q1. So let's look at an example. The blood glucose of 30 females is recorded. The results are shown in this stem and leaf diagram. And we must find any outliers. And we're told that the data is discrete. And the key here tells us that 2.1 means 2.1. So for example, this number here means 3.2. So, let's find the outliers. Now to do that, first of all, we need to find Q1, Q3 and the interquartile range. And remember that Q1 is in the n over 4 position and Q3 is in the 3n over 4 position, where n is the total number of observations. So first of all, let's find n. Well, very helpfully, this stem and leaf diagram, you can see over here, we have numbers in brackets. And what they have done is counted how many data values are in each row. Because every one of these numbers on the right stands for one piece of data. Now we could count up all of those numbers, but as I've said, over on the right-hand side, they have already counted the rows in brackets. So what they're saying is that in this row there are 6 pieces of data. So that means to find the total number of pieces of data, all we have to do is add up these numbers in the brackets, much quicker than counting all of the numbers. And we can do that and see that n equals 30. Now that we know n, we can work out the position of Q1 and Q3. And we see that for Q1, n over 4 is 30 over 4, which is 7.5, and 3n over 4, 90 over 4, which is 22.5. Now this is discrete data, so just a quick reminder of the rules. And basically, because it's discrete data, we are interested in whether n over 4 or 3n over 4 gives us a whole number or not. Now for us, in both cases actually, we do not get a whole number. N over 4 is 7.5, so we're going to round that up to 8 and say that Q1 is in the 8th position. And for Q3, we got 22.5, let's round that up to 23, and Q3 is in the 23rd position. So now we just need to find the 8th number and the 23rd number, or data values, in the stem and leaf diagram. So let's go back to our data. Now all we have to do is count through the data in ascending order. Now this number here is our lowest number. This number is our highest number. So to count through the pieces of data, actually what we're going to do is start here and just count along the first row and then along the second row and so on until we get to the 8th position and the 23rd position. So let's do that. And we can see that counting through, the 8th position is here, and the 8th position stands for 3.2. We have the 3 stem, leaf of 2, and the key told us that that means 3.2. And for Q3, which was in a 23rd position, so stem of 4, leaf of 0, using the key, we have Q3 equals 4.0. So we need the interquartile range, Q3 minus Q1. Q3 was 4.0, Q1 was 3.2, so 4 minus 3.2 is 0.8. Okay, we know the interquartile range, but we're interested in outliers. And remember our formulas for testing for outliers, we need to do these two calculations. Q3 plus 1.5 times interquartile range, and Q1 minus 1.5 times interquartile range. So let's substitute in for Q1, Q3 and the interquartile range. And what we find is that we are interested in the numbers 5.2 and 2. So that tells us that an outlier is either greater than 5.2 or less than 2. So let's go back to our data and see if we have any outliers. And here's the data. And looking at our data, we can see that actually there are no values less than 2. Yeah? There is nothing here. Yeah? Nothing at all. All of these numbers, all of them are 2 point something greater than 2. But we do have one value greater than 5.2, and it's here. This one isn't. This is 5.1, but the second one is greater. This one is 5.5. So we only have one outlier, and it is 5.5. So that's an example of finding outliers. Now try the question.